Okay, so for today's lesson, we are going to form a straight line in order to find the constant values m0 and t. So in this question, we are given some t values and the corresponding m values. Okay, so please kindly take note. Sometimes one of the value, they may purposely give you the wrong value. So later when you plot, you realize that any point that is out of the straight line, it may be done on purpose. Okay, they purposely give you one wrong values. Okay, so sometimes they do that. So in this question, we are asked to plot ln m against t. So we need to manipulate such that your capital Y will be your ln m. Okay, let me change the color. Your capital Y will be your ln m, and your capital X will be your t. So what does it mean? Later when we form y equals to mx plus c, this one must be ln m, this one will be t. So our m will be a combination of constants. I don't know which one yet. C will be a combination of constants. What do I mean by combination? A combination of constant means you will be involving these two constants here. So we will see very soon. Now, what must I do in order to form into a ln m? Very obvious, right? I must ln both sides. So let's start with this. M equals to m0 e power negative kt. I ln both sides. Okay, so if I ln both sides, what will I get on the right hand side? Can we skip one step? By now you should know already. Ln m0. No. Okay. Yep, but you plus, then later you bring down the negative kt. So our minus kt ln e. So ln e will be just 1. So we will have, because I cannot skip too many steps. Ln m0 minus kt. Now be very clear which is your capital Y, which is your capital X, which is your gradient, which is your y-intercept. So which one is which? Your ln m is your y, right? Where is your gradient? This one is very important. Your gradient is negative k. Where is your x-axis? Will be your t. What is your y-intercept? Okay. So later we will plot the graph and you will use the actual graph to help us to find what is the gradient so that we can compare. To find k, we will find where is the y-intercept so we can compare and find the value m0. Okay? So what we will do now is this. We are going to plot ln m against t. You realize that there is no ln m. Yep, so yesterday I already asked you all to do, so we'll speed up a bit of time. And the values 3.71, 3.29, 2.87, 2.45, 2.03. Okay, so we speed up. We just press ln this, ln this, ln this, ln this, ln this to get the values here. Now, after I plot, which x and y values do you plot? I'll plot ln m versus t, right? So I don't need this. I will erase here so that we don't get confused. So let's plot 5, 3.71. So 5, 3.71. Okay, plot all the way to the last one, 25, 2.03. Okay, good. As we plot, you make sure your straight line cuts the y-intercept. When you all study science, you all got study something called a broken line for the x and y axis. Do not have broken lines. Can someone tell me why? Do not have broken lines for the x-axis. Can someone use simple English and explain why you cannot have broken lines? So for example, if the first number is 20, right? You don't put a broken line, okay, and then start from 20 straight away. You must still do from no broken line, 5, 10, 15, 20, and so on, or no broken line, 10, 20, 30, 40, no broken line. Why? You need the y-intercept. With a broken line, the y-intercept is wrong, right? So you cannot have a broken line. So no matter how small your graph look, or no matter how lopsided your graph looks, you cannot have broken line for the x-axis. Now, how do you think we can estimate the values of k and mo, or m0? How do you think we can do that? Yes, this will be, k will be part of the gradient, and m0 will be part of the y-intercept. Now, if the question is like this, you can still find gradient and y-intercept. So don't care what this is, okay? Don't care what this look like. You always find the gradients, you always find the y-intercept. So the next part of the question is always finding the gradient, finding the y-intercept. So let's find the gradient. Let's find the y-intercept. It's standard one, it's standard, so don't have to worry. Okay, gradients will be, yeah. So you can usually just take y1 minus y2. Okay, in this case, this is your y1 minus y2 over x1 minus x2. So the y1 will be this number. Now, when you use these points and this point, please make sure that these 2 points really lies perfectly on the straight line. Really lies perfectly on the straight line. Okay, I done this already, so I know it lies perfectly on my straight line. So I use this one, minus y2 over x1 minus x2. So what was the gradient? Negative 0.084. Now look at the y-intercept. It will be 4 point. Okay, yeah, my y-intercept is also 4.1. Okay, now your y-intercept is a bit different. It's fine, around there, 4.1. Okay, 4.125, 4.1, and so on. Now these 2 steps are standard, but when you compare, please be careful, compare with this. So negative k is equals to your negative 0.084. Okay, so the actual value of k will be 0.084. Okay, later I'll tell you what this means in a while. Now your y-intercept is 4.1. So what must you write next? Yep. Your ln m0 will be 4.1. How do I find m then? M0, how do you find? Yes, e to the power of 4.1, and the answer is 60.3. Okay, if you get 62 point something, it is fine. We got slightly different answers. I want to estimate the number of hours for the mass to be halved. What must I do first in order to know whether the mass is halved? Okay, so let's sub in the k and m0 first. So this is part 3. Okay, if I sub in the m0, it will be 60.3. If I sub in the k, it will be 0.084. How do I know when is it halved? What is the mass when it's halved? You want to know when's the halved mass, what is the value? Yes, you need to know initially how big it is. Yep. So when t is 0, initially what's your mass? You need to know initially what's your mass, then you know how much to halve it. So when t is 0, m is, okay, it is 60.3, because this value here will become 1. Anything to the power of 0 is 1. So I need to halve this. So if I halve it, okay, you can write anything you like. I just write as half it, like this. Okay, so if I halve it, what do you think I'll get? 30.15. 5. Okay, so this is the algebra part already. How do I find the time?
You let this one equals to
You let 30.15. B equals to 60.3. Okay, then you see something very interesting come out. Then you say, yeah, I should have done that. If I bring this over, what do you think I will get? Yeah, I bring this value over, I get half. 30.15 divided by 60.3, I get half what? Okay, so if my mass is half, I'll get this. Okay, let's do our ln both sides. Ln both sides. Very simple, right? Ln E by now we have seen many times is actually equals to 1. So ln half equals to negative 0.084t, and the final answer is, okay, that's all. Brian?